Next, we're going to do a quick review on graphing piecewise functions and evaluating piecewise functions. This is homework problem 40 from section 2.3. It says k of x is equal to the piecewise defined function 2x plus 1 when x is less than or equal to negative 1, 2x squared minus 1 between negative 1 less than or equal to 1, and 1 minus x squared when x is greater than 1. First thing is evaluating piecewise functions. If I want to evaluate what, and these should all be k's, what k of negative 3 is, I need to figure out which one of the piecewise defined portions that I'm going to use. Well, negative 3 is less than negative 1, so I'll use the top function. Negative 3 times 2 is negative 6. Negative 6 plus 1 is equal to 5. Similarly, when k equals 1, I would use the middle portion of the function because x less than or equal to 1, 1 would fit in there. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. When x is 0, again, it falls into this middle section. 0 squared is 0 times 2 is 0 minus 1 is negative 1. And when k is 4, again, the k of 4 is substituting a 4 in for x. 4 squared is 16. 1 minus 16 is negative 15. So that's how you evaluate a piecewise function. It's just like evaluating a regular function, but you need to determine which piece that you are going to use. Now for graphing piecewise functions. Again, make sure you're doing them in pencil so that you can erase. So we want to graph all three of these functions, then we want to erase those areas where the domain is not within that portion. So the graph of 2x plus 1 is a graph that has a slope of 2 and a y-intercept of 1. So if I were to graph that line, it would look like this. Well, my domain is only x is less than or equal to negative 1. Well, here's x is negative 1. So this portion of the line would remain, and basically that line turns into a ray. Then you graph the second piece of your function. This is 2x squared minus 1, which is the memorized right side up parabola that shoots up faster, shifted down 1. So if I go over 1, I'm going to go up to a total of 2 instead of 1 for my parabola. Over 1, up a total of 2. Over 2, well, I don't have to worry about it because it only goes to 1, but I'll do that. And it's going to go up a total of 8. My parabola looks something like this and like this. But now I need to restrict it to its domain. Well, negative 1 is where it starts, but it doesn't have a value on that function at negative 1. And positive 1 is where it ends, and it does have a value, so I need to make sure to have a solid dot. And my last graph is an upside-down parabola that has been shifted up 1. So upside-down parabola shifted up 1. Well, if I go over 1, I'd end up going down 1. If I go over 2, I'd end up going down a total of 4. This is the general shape of that upside-down parabola, and it would repeat on this side. But I don't need the whole graph. I only need the portion that starts here and continues down forever. So now let's check our stuff out here. Negative 3. If I put a negative 3 into the function and I had this graph continuing, yes, I'd get negative 5. If I put a 1 into the graph, yes, I get 1. If I put a 0 into the graph, yes, I got negative 1. And if I put a 4 into the graph, I'd be down here at negative 15 on this parabola.